Welcome back, students. I'm about to show you how to simplify complex fractions, and the first example you see right here is a complex fraction because it's a fraction over a fraction. Now if you just have two fractions, like 2c over 3 and c over 6, if you want to, you could think of this as division and do it this way, right over here. Okay, I'm going to do it this way first. We bring it down because this is doing division that you just learned. We change the division to times, and we do the reciprocal of the second fraction. So that's 6 over c. Now we cross cancel, the c's go out. And then the other way, 3 into 3, 1. 3 into 6, 2. And that'll give you 2 times 2, which is 4. And the bottom is just ones. You could have a 1, but you don't need the 1 because 4 divided by 1 is the same as 4. So the simplest answer is actually 4. Okay, now let's go to another method. Now this next method I'm about to go over with you is very useful when the problems get more difficult. This is the easiest example. So as I said before, if you just have one fraction on the top and one on the bottom, you could use the other method. But now I'm going to show you the LCD method. The LCD, as you know, is the least common denominator, and you're looking just at the denominators, 3 and 6, and you're asking yourself, what's the least or lowest number that 3 and 6 go into evenly? Always start with the largest number, in this case 6. It works because 3 goes into 6 evenly, 6 goes into 6 evenly. If it didn't work, you could double it, try 12. If that didn't work, you could triple it, try 18. And if that didn't work, you multiply the two denominators and use 18. But in this case, we're using the least number so that we have less simplifying to do. Okay, so we're going to use 6. And now using 6, you multiply everything by the 6. What do I mean by everything? Each component in the problem. 2c over 3 and c over 6. You multiply each of them by the LCD, in this case 6. Okay? Every time you do this method, things will cancel. 3 into 6 goes 2. 6 into 6 goes 1. Okay? And now we're ready to write the answer. 2 times 2c is 4c. Okay, the bottom is 1. There's only a c here, so 1 times c is c. Now we do have the right answer, however, you could simplify some more, and that's what you got to get used to doing when you do complex fractions. Always check to simplify. In this case, the two c's will cancel each other out, and your final answer will be just 4. Okay, that's it. In about 10 seconds, you'll get to the second example. That's it for now. Okay, students, welcome back. You're ready for example 2 of 3. This one is more difficult than the one we did before, so make sure you practice these and pay close attention to this. This one is very complex. It has a fraction here, a fraction line, another fraction. So to do this, we're going to use the LCD method. If you try to use that method where you divide, it's going to be too long and too complicated, so please learn this method. Now in order to do this, you have to make everything into a fraction. 3 over 1 is the same as 3. Same thing here. And we need the LCD. Now remember, we're looking at the denominators, which I'm circling. So you say to yourself, what's the least thing I could put here where all of these denominators will go into? Now with the ones, you don't even have to worry because 1 goes into anything. But between the two letters, n and n squared, same letter, you use the highest exponent. So n squared. And the reason that works is because n goes into n squared evenly, n squared goes into n squared, and of course the 1's go into it. As long as everything in the denominator divides into it evenly, you have your LCD. If you use something bigger like n4, n to the 5th, it would work. However, you'll have more reducing and more work to do. So always use the least if you could find it. Okay, now we're ready to multiply everything by the LCD. Everything means this one, and this one, and this one. Okay, and remember I mentioned that every time you do this, things will cancel. N into n squared cancels. You're just subtracting exponents using a basic law of exponents, and you'll get n, or n to the 1. Okay? And then over here, nothing cancels. Over here, nothing cancels. But over here, you have two n squareds. They both cancel. Okay? Once you do all the canceling, you're going to write what's left. So we're left with n times 3, which is 3n. You copy the sign, plus, and then the 1 you don't need, so 3 times n squared is 3n squared. Then on the bottom, you have n squared times 3, that's 3n squared. You copy the sign, minus, and then you have 3, there's nothing left, so it's just 3. Okay, now don't think you're done when you do this. You have to try to simplify this, and in order to do that, it's going back to the very first lesson on fractions. You always factor where possible, and you try to cancel, so let's do that. There's a 3 in common, and there's an n in common. You remember to take out the lowest, which is n, or n1. So we take out a 3 and an n, common factoring, and we get 1 plus n. Okay, now let's look at the bottom. There's a 3 here, so we take out a 3, and we're left with n squared minus 1. Okay, now you got to be careful and look closely. This is not fully factored. So we're going to do it again and factor some more. This one is already factored fully, so we'll just copy it. Okay, the bottom, do you see this part? This is difference of two squares. So we're going to factor like that, just the way you learned it. Two n's, two ones, a plus and a minus. Okay, now it's fully factored. So now we're going to try to cancel. Notice 1 plus n is the same as n plus 1, commutative property of addition. Just like if we had a number here, let's say this was a 5, isn't 1 plus 5 the same as 5 plus 1? Same thing. So in algebra it works the same way. If you reverse it, they're exactly the same. So they cancel out. Also the 3's cancel. 3 into 3, 3 into 3. Those are just 1's, but you don't really need that here, so we'll leave out the 1's. The final answer, you're left with an n on the top, and you're left with an n minus 1 on the bottom. Now, since that's all by itself and it's not being multiplied because they canceled, you could just leave out the parentheses and just write n minus 1. Okay, and that's it. That's your answer. Okay, in about 10 seconds, you're going to get example 3, which is probably the most difficult. So hang on. Okay, students, you're ready for example 3, the third, and probably the hardest example. Okay, now if you look at this one, there's a fraction here, there's a line here, which makes it a fraction with a line and another and a denominator. When you have this, you got to make everything into a fraction. So this is over 1. Okay, now this is a binomial. However, to do the problem, we're going to put it over 1. This way we make everything into a fraction. And now we could use the LCD method. Okay, in this case, the LCD is very easy because 1, 1, and x, the only thing you need is an x. Because x goes into x, and 1 of course goes into anything. So we have to multiply everything by x, and here's what's going to happen. X here, now remember you got to do it for everything, not just here and here, but down here also. You're going to multiply x times the binomial x plus 4. Now notice, this would be wrong if I did it like this, because you're multiplying by the entire binomial, and to show that, you put a parenthesis, just like that. Okay, now we're ready for the next step. We're going to cancel. Okay, those x's cancel. Nothing cancels here. Nothing cancels here. So now we have to rewrite everything. You're left with 16. Take away. X times x, as you know, is x squared. Okay, now you could distribute, but don't do that. If you distribute, you won't see what's going to cancel. So leave it as a multiplication, exactly as you see it. X parentheses x plus 4. Okay, now you don't need the 1 on the bottom. Okay, again, we did this correctly, but we're not finished. Why? Because you have to check the factor. If you look at the top, isn't this a difference of two squares? So we're going to factor it as a difference of two squares. We get 4 plus x and 4 minus x. Okay, the bottom is already as a multiplication, meaning it's already in a factored form, so you don't have to do anything, just copy it. That's why I said don't distribute, because you wouldn't notice what to cancel. Okay, and now you'll see a x plus 4 and the reverse 4 plus x. Now remember, that's commutative with addition. Commutative doesn't work with subtraction. So don't think of it as subtraction that way. In this case, we could cancel these two out, and the final answer is 4 minus x over x. And we're done. That's simplified. Do not cancel a monomial with part of a binomial, because this x is a monomial and the 4 minus x is a binomial. Canceling the x's would make it wrong. Leave it just like that and you're done. Okay, now you could start the homework, and if you're able to do it, great. If you're having trouble, please email me and let me know, and I'll try to answer it.